Hey everybody, in this video we'll talk about graphing rational function with holes. So let's say we're given this rational function. In my video on constant over linear, graphing constant over linear rational functions, I talk about the 7-8 steps of graphing a rational function. But we got to be a little careful because this factors into x plus 2 times x plus minus 2 all over x plus 2. Now if you notice one thing is that the top has a factor in common with the bottom. So what happens when that is the case is that these factors are going to divide out and go to 1. Okay, that's a 1. And we're going to be left with x minus 2. But be careful, because if I were to just plot the line x minus 2, I'd have a y-intercept of negative 2, and then I would go up 1 over 1. I would have a slope of 1. But that means that I could plug in 2 and expect to get an output here. However, if I plug in 2 to f, what happens? Well, I'm going to get 0 on the bottom. Right? So that doesn't work. We get something undefined. So be very, very careful. Instead, what's going to happen, because we know from the original function that x cannot equal negative 2. We would have an asymptote there if we didn't have a similar factor on the top, but instead what we're going to have at x equals negative 2 is actually a hole. So it's basically saying, hey, this function is going to act like this line, except for at this x is negative 2 value. And how do I find, let's say it's not this nice easy line, how do I find where that y value is going to be? Or would be? Because I can't just plug in negative 2, right? But I can plug in negative 2 into the function that f is kind of acting like, which we will call g. So in this case, that's negative 4, which we can see my hole is going to be at negative 2, negative 4. So it's really important to make sure you plot your holes correctly. So let's do another example. Let's take a look at this problem. F of x factors into x minus 1 times 2x plus 3 over x plus 4 times x minus 1. So I can see that I have a factor in common. So those are going to go to 1, and I'm going to get 2x plus 3 over x plus 4. So f of x is equal to this function, except x cannot equal 1. Because if I plug in 1 to my original function, I'm going to get 0 on the bottom. So what I do is I graph this new function. This new function has a asymptote at y equals 4. So let's do the steps on this new function. F of 0 on the new function is going to be 3/4. So I have a point at x is 0 and y is 3/4. It just wants to keep zooming in and in for you today. 3/4. And it's not negative, so 0, positive 3/4 is about right here. My next step is to let 0 equal my function. This is going to find my x-intercepts. I can multiply both sides by x plus 4, and now I'll just end up getting 0 equals 2x plus 3. Subtract 3 and divide by 2, I'll get x equals -3/2. So at 0 and x is -3/2, I'll have a point. Step 3 is to find the vertical asymptote of the new portion, which is at x equals -4, or where the denominator equals -4, so that is here. Alright, now the fourth step, to find the horizontal asymptote, or maybe the slant asymptote depending, but my numerator is equal to the degree of my numerator is equal to the degree of my denominator, so my horizontal asymptote is at y equals 0. Guess what it crosses? I already found that value where it does cross. Okay, but we know x cannot equal 1. So when I start plugging in points, if I plug in 1 for x into my original function, I'm going to get undefined. But if I plug it into my new function, there's going to be a hole at this point. And that happens at 2 times 1 plus 3 divided by 1 plus 4, which is equal to 5/5 or 1. So I will have a hole at 1, 1, like this. Now I made one mistake here, and that is my degree of the numerator is not equal to the degree of the denominator. So I don't have a horizontal asymptote at y equals 0. N equals m. So I take a look at the leading terms, which equals 2. So my horizontal asymptote is at y equals 2. Maybe you guys caught that as you were going through this video. So that's what it should look like there. Then I have these 3 points here, and I know my function's going to go towards my asymptotes, like that. And then I can plug in some points on the left-hand side of my asymptote of -4. When I plug in -5 to my function, I'll get 7. And when I plug in -7, I'll get 11/3. Remember, I'm plugging it into this new piece. Okay, I'll actually end up getting the same thing either way. But at -5, I'm at a +7. And then at -7, 6, 7, I'm at 11/3, which is almost 4. So I'm going to have a function that looks like this.